Quantum computers can be super powerful, but they're also very sensitive. That's why most of these quantum computers have to be operated at nearly zero temperature. This is one of the factors that makes development quite challenging. But what drives people working on quantum computers? What motivated you the most?
The biggest motivation, I think, is the technical advances and just seeing what technology is able to do and how fundamental things in nature we can see with technology today.
I think one of the most challenging aspects is, in general, learning how to be patient. One thing that I do is a lot of fabrication. When I talk about fabrication, I mean building the device basically almost from scratch. Whenever you manage to succeed and complete the fabrication round, you really get a spike of dopamine in your head, and yeah, that's very nice. What we investigate in our group is what we call quantum materials. Especially, we investigate the structures that host spin qubits, and in particular, we do it with semiconductor heterostructures. So part of the people in our group, they grow the heterostructure, while I build what we call the gate stack, so what's on top of the heterostructure to actually make the quantum dots.
Okay. What would you say is going to be the future of this?
I think it's going to be some interesting time looking ahead on how quantum computers in general are going to scale, how that's going to have an impact on our life and society. I think we're still very much in the infancies of things. You know, you can compare it to the early 60s or 70s of regular computers, where no one could have predicted that we're going to have social media today, for example. And so I think it's also very difficult to predict how quantum computers are going to affect us, how that trajectory is going to pan out, and how quickly that's going to pan out.